Hi guys! In today's video we will be focusing on hexadecimals. Hexadecimals are always to the base 16. By base 16 I mean 16 to the power of 0, so on. Now, how will you notice when they give you a hexadecimal? You'll notice them if they clearly have a little h on the side, this little h over here, or if they have a letter in it. All you need to know is that letters A to F represent numbers 10 to 15, like so. An example on how to convert a decimal to a hexadecimal. Now, the first rule is you should always remember to convert any decimal to a binary first, and then the binary will be converted to a hexadecimal. So that's our first rule. Let's make a note. We should always convert to a binary, and then our binary will be converted to a hexadecimal. Now, the example I'm going to be giving you is 16. 16 is the decimal. So let's put a little d over here. This represents a decimal. We want to convert this to a hexadecimal. This is n, any number. We don't know what this is yet. So this is any number, but it's hexadecimal. What we do is we find out what the binary for 16 is. So that was our first rule to convert to binary. 16 as a binary is 0, 0, 0, 1, 0, 0, 0, 0. Now we've got this. We've got our binary. Now to convert to a hexadecimal, we need to split this binary into groups of 4. So how many digits are there here? There are 1, 2, 3, 4, 5, 6, 7, 8. There are 8, so that means we can split them into 2 groups of 4s. So we can split it right down here, can't we? Okay. We have to treat them separately. What we can do is we can do 2 to the power of 0, which is 1, 2, 4, and 8. 8 times 0 is 0, 4 times 0 is 0, 2 times 0 is 0, 1 times 1 is 1. So our answer for this separate group is 1, is 0 here. This shows that our answer, our hexadecimal answer is 1, 0. You could put a little note here so you don't get confused. It may look like a 10, but it's not. Whenever we're dealing with a hexadecimal, we always treat each value separately. The answer was 1, 0, which may look like a 10. Okay? I want to show you how to convert a hexadecimal back into a decimal. So this is our hexadecimal. Like I said, we treat each value separately. Our 1, 0 we can split, and now because we're starting with a hexadecimal, we are now dealing with base 16. If we were starting with a decimal, we would be dealing with the base 2. But base 16, so over here would be 16 to the power of 0 and 16 to the power of 1. So anything to the power of 0 is 1, and anything to the power of 1 is itself. What this means is there is 1 lots of 16 and there is 0 lots of 1s. So that's 16 and 0. When you add these two together, it gives you 16. Now we are going to be dealing with a more difficult example, how to convert 142 decimal to a hexadecimal. Remembering n is anything, we don't know what it is yet, but we know that it's going to be a hexadecimal. Like I said, we always need to know what its binary is first. So 142 as a binary is 1, 0, 0, 0, 1, 1, 1, 0. We do this by dividing by 2 until we get to 0. Now, because we're starting with a decimal first, we have to use base 2. And like I said, we need to split binary into groups of 4s. So there is 4 digits here and 4 digits here. We have to treat them separately. This is one group and this is the other group. Now, like I said, we're using base 2. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So that is 1, 2, 4, and 8. So there is 1 lots of 8, add 0 lots of 4s, 0 lots of 2s, and 0 lots of 1s. There is 1 lots of 8, add 1 lots of 4, add 1 lots of 2, add 0. Now the sum of all of this is equal to 14, and the sum of this is equal to 8. Now, when dealing with hexadecimal, we have to remember that wherever we can, we have to place a letter. So 14 is greater than 10, so we know that we're involving a letter. 14 is equivalent to E. So this bit is equivalent to E, and this bit is not greater than 10. So 8 is less than 10, so we do not use any of these letters. So this is just equal to 8, and this is equal to E. So our hexadecimal answer will be 8E. That's how we convert a decimal to a hexadecimal. And I am going to show you how to convert a hexadecimal back into its decimal. Now, because we're starting with a hexadecimal, we are dealing with base 16. All it is just 16 to the power of 0 and 16 to the power of 1. Why? Because there are only two units here. So let's split this. E, 8. 8E. 16 to the power of 0 is 1. 16 to the power of 1 is 16. So what this means is there are 8 lots of 16s. Add 1 lots of E, and E is equivalent to 14. What we have to do now is just find the sum of these, which is going to be equal to 142. And this is the decimal which we started with in the first place. Now, for our next example, we are going to be dealing with how to convert the decimal 357 to a binary and then to a hexadecimal. First, we need to know what the binary is, and all we do is divide 357 by 2 until we get to 0. So what I got was, okay, so this is our binary done. Yep. Now, we want to convert this to a hexadecimal though, and to deal with any hexadecimal or decimal, we need to make sure that our binary is in a group of 4s, that they can be split into 4s. So this one can be split, this one can be split, but this one can't be split. There's no 4 digits here. So what we do is we add 3 zeros to the front. Because now we're starting with our binary and we want to get to a hexadecimal, binary is always in base 2. So what we do is we always treat these separately. That's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. That's anything to the power of 0 is 1, 2, 4, and 8. So that is 4 times by 1, add 1 times by 1. This is 4 times by 1, add 2 times by 1. This is just 1 times by 1, because there is 0 lots of anything over here. There's 0 lots of those, and there's 0 lots of, and there's 0 lots of those. So the sum of this is 1, the sum of this is 6, and the sum of this is 5. We don't add these. We never add these when we're dealing with a hexadecimal at the end. We just write them down as it is. That's 1, 6, 5. This is our hexadecimal. Now, I will quickly be showing you how to convert the 165 hexadecimal to a decimal. Like I said, each digit gets treated separately. So, and because we're starting with hexadecimal, we have to use base 16. So 1, 6, 5. That's 16 to the power of 0, 16 to the power of 1, and 16 to the power of 2. Thanks for listening, guys. I hope you enjoyed this and I hope you found it somewhat helpful. Come back for more later videos. See ya!